Today we're going to continue looking at lesson 7.4, which is about division properties of exponents. So today's objective is we're going to use division properties of exponents. So let's go ahead and take a look at some more examples of this property. So remember, our definition said that as long as you have the same base, like if I have an x to the m divided by an x to the n, so they both have the same base of x, I'm going to keep the base and I'm going to take the top exponent and I'm going to subtract the bottom exponent from it. And remember, when we do that subtraction, we originally think of it in the numerator of a fraction. Okay, so let's keep that in mind. I'm going to look at this first problem here. We've got 3y to the fourth x squared all over 4x to the third y squared. So the first thing I'm going to look at are my numbers. Because I'm dealing with division, if I can actually divide and simplify down those numbers, then I want to do that. But because a 3 and a 4 don't have anything in common, that means I'm going to keep the 3 on the top, I'm going to keep the 4 on the bottom. Now, if that 4 was really like a 9, well, then we'd be able to reduce down those numbers. It's just that we can't in this. So the next thing that I see on the top is a y. I see another y on the bottom. It's just in a different spot. But notice that when the bases are the same, I originally keep the base in the numerator, and based on that definition, I take the top exponent and I subtract the bottom exponent. So it'll be 4 minus 2. I also see an x on the top and I see an x on the bottom. So once again, they have the same base. I keep the base originally on the top. I take the top exponent, which is 2, and I subtract the bottom exponent, which is 3. All right, so I'm going to keep simplifying this. So I'll have a 3 on the top and a 4 on the bottom. That's not going to change. I have my y, and when I subtract my exponents, 4 minus 2 is 2. I'm going to keep my x, and then I'm going to subtract the exponents. Well, 2 minus 3 is negative 1. I don't see any more bases that are the same, so that means that I don't have to try to simplify that. The only thing that I notice is that the x has a negative exponent. My final answer has to have positive exponents. The y has a positive exponent. Technically, the 3 has a positive exponent, and so does the 4. So the only thing that we have to move is the x. Remember, if it starts on the top, we're going to move it down to the bottom. So my final answer, keep the 3 on the top, keep the y squared on the top. On the bottom, we still have the 4, but now that x gets moved down. And because we had to move it down, that technically has a positive 1. You can write that positive 1 if you want. You don't have to, but no bases are the same anymore. This is as simplified as we can get it. If we take a look at the next problem, I have division. So I see that I've got an A on the top and I've got an A on the bottom. So I'm thinking about my definition where I keep the A originally on the top and I take the first exponent on the top, which is negative 3, and I'm going to subtract the bottom exponent, which is also negative 3. I only see one B in this problem, and it starts on the top, so I'm going to keep it on the top. So right now, then, it's really all over 1 because there's nothing else in my denominator. And now I can keep going. Because I'm subtracting a negative, that means that we get to change both of those signs to a positive. So now A is raised to the negative 3 plus 3. Well, negative 3 plus 3 is going to give us 0. Notice that this is something that I can continue to simplify. If I have an a to the power of 0, well, anything to the power of 0 is 1. I still have the b. It's technically all over 1. So then just to simplify, because 1 divided by 1 is 1, we don't really have to write the 1s. B has a positive exponent, so we can keep the b where it is. So B is my final answer. If I look at the next problem, I see that there are several variables and I see that there's parentheses. So if we think about order of operations, PEMDAS, notice how we start with parentheses first and then we move on to exponents second. Okay, so I'm going to look at the parentheses first. In my parentheses, I see a y on the top and I see a y on the bottom. So I'm going to go ahead and I am going to start combining those, because if they have the same base, I'm going to be able to combine it. So the x to the fifth is going to stay where it is. Remember, because this is division inside of the parentheses, I keep that base on the top and I take the top exponent and I subtract the bottom exponent. Because there's no other things in the denominator, it's now technically over 1. And this is all still being raised to the second power. Well, I'm going to keep simplifying. The fact that now I can subtract my exponents. We have the base is y. We have negative 4 minus 7. That's going to give us a negative 11. Okay. Now that I have no more bases the same, we can technically drop that denominator. I have an x to the fifth, a y to the negative 11th, and that's being squared. So I took care of parentheses. There's no other bases that are the same in the parentheses. So now I get to move on to the exponents. In this case, we have a power inside and we have a power outside. So this is a power to a power. If you remember the definition, if I have something like x to the m being raised to the nth, that means I keep the base and I multiply the exponents together. So I am going to keep that base of x and I'm going to multiply its exponent of 5 times the outside exponent of 2. I keep the base of y, I multiply the inside exponent of negative 11 times the outside exponent of negative 2. That gives us then x to the 10th power and y to the negative 22nd power. So the last thing that I see is that I can only have final answers as positive exponents. X has a positive exponent, but y doesn't. So now I can go back to thinking it like a fraction. Only the y that has the negative exponent will have to get moved so it can turn into a positive exponent. So x to the 10th is still on the top. Now the y moves down to the bottom. Its exponent becomes a positive. Because those bases are different, I cannot combine them any further. This would be my answer. If we look at the next example, I see a bunch of division. I notice that I see a number 14 on the top and I see a number of 2 on the bottom. So because this is a division problem, I can divide. 14 divided by 2 is going to give us 7. Because the bigger number is on the top, that means the 7 is going to be on the top. I see that there's an M on the top and there's an M on the bottom. So because this is a division problem, I get to keep that base of M on the top. I take the exponent on the top, which is 3. There's technically an exponent of 1 on the bottom. I'm going to subtract them. I see that there is an N on the top and I see that there's an N on the bottom. So following our division rules, I get to keep that N on the top and I get to take that 2 and I get to subtract 4 from it. I see that there's a P on the top and there's a P on the bottom. I get to keep that base of P on the top and I'm taking negative 2 minus 7. Because then there's nothing else left over in the denominator, it's all technically over 1 to start. All right, so now if I start simplifying, we keep the 7, but now I'll have m raised to the 3 minus 1, so now it's an m squared. I keep the n, and I take 2 minus 4, which is negative 2. I keep the p, and I have negative 2 minus 7, which is negative 9. That's still all over 1. Because I don't have any more bases that are the same, I can't combine those any further, but my final answer can only be positive exponents. Technically, the 7 has a positive exponent, it's a 1. The m has a positive exponent, but notice that the n and the p do not. Those are going to have to move down to the bottom. So my final answer, I keep the 7 and the m squared on the top. You can write the 1 if you want, but you don't have to. So then the n moves down to the bottom, changing its exponent positive. The p moves down to the bottom, also changing that exponent positive, and this would be my answer. All right, I would suggest that you pause the video and try these two checkpoint problems. Okay, hopefully you did that. Let's take a look. Because I have the same base, I get to keep the base, and division means I take 7 minus 8. This is technically on the top, so it's all over 1. Well, 7 minus 8 is negative 1. I cannot have negative exponents, so I get to move that down to the bottom, which means that my final answer should be 1 over x. If I look at the second problem, we have a 24 and a 6. This is a division problem. 24 divided by 6 is 4. The bigger number's on the top, so 4 gets to be on the top. I see that there is an x on the top and an x on the bottom. So I get to start with the x on the top, and I get to subtract the exponents, so 5 minus 4. I see that there's a y on the top and a y on the bottom. I originally start with the y on the top. I take negative 2 minus 3. Because there's nothing else left over in the denominator, this is all now over 1. So I get to subtract my exponents. We'll have 5 minus 4 is positive 1. And with the y, negative 2 minus 3 is negative 5. Hopefully we notice that I can't have negative exponents. That y has to get moved down to the bottom. But the 4 and the x stay on the top. The y moves down, changing its exponent positive. No bases are the same, so this is my final answer.